Well, hello, Cal State Straub. We're back for the second day on 10-2. You will be very happy to note that this is just 4 small slides, so this session is not going to be very long. Yay! There's just a couple more things from section 2 that I didn't hit in the very first lessons. Split them out, and that will be there'll be times when we do something called a paired T procedures. So I've got the explanation here. Move my big fat head out of the way. Okay. To compare responses to 2 treatments in a matched pairs design or before and after measurements on the same subjects. If you remember back to chapter 5, we talked about we could do an experiment, matched pairs like left boot, right boot, and compare those treatments, or we had the same subjects and we gave them did something before or after and took 2 measurements on the same people. Okay. If that's the case, we still apply the one sample T procedures just to that difference, because our sample, it is one sample. It's not 2 separate samples from 2 separate populations. That's what a 2 sample will be when we get to it. A 1 sample is just, I got 1 sample of data and it's just the differences between, and I will tell you up front, the chapter test has a paired T on it. So let's see what we could do here. So we're going to do a 90% CI for the mean change in the depression score. This is a problem that I took from your book that I just wanted to put here. They tested to see patients who were experiencing depression. They took a test on it to see what it was. And if they took caffeine or a placebo, what was the thought? So this is the same subjects. We have 11 subjects here. And this is the one time they did with placebo, one time with caffeine pill probably, or something like that. Okay. And so we did placebo minus the caffeine. Whenever you're doing a paired T on differences of things, you always need to note, like I did here, what it is the direction of your differences. Okay. Because of course these would become opposite signs if I had done it caffeine minus placebo. So this is the placebo minus the caffeine, and I get my scores. The reason it's important to state that is because when you go to do your conclusion, that will help you to remember, like if you end up with a CI that's positive, then you know that the placebo was more than the caffeine. Whereas if it's negative, then we know the caffeine was higher than the placebo. Okay, so we do need to state that. So the first thing you do is I listed this and I took the differences between them all. Okay, so let me move my head as my clock goes on. Okay, that means it's 4 o'clock. It's on Thursday for me. This is not assigned till Tuesday. So, all right, calculate the difference between the 2 scores like I did. We still check conditions then, but now what you're checking it on is this purple set of data. This is what goes in your calculator here for the 1-bar stats. Okay, calculate the difference between the 2 scores. Check your conditions on those. Make a probability plot. Why? Because n is not greater than 30, greater than or equal to 30. I have only 11 here. That's even less than 15. So I need to make sure that the plot looks normal and that I don't have any outliers. Okay. So as I do, I see I get fairly normal plot. I'm okay. I run 1-bar stats and get my X bar and my S because I don't have a standard deviation of the population given to me in this. So I'm going to use the estimate with the standard deviation of the sample. Remember, this is though the standard deviation of the sample means of everything, right? The mean difference all put together. Okay. All right. DF need to calculate. There's 11. So 11 minus 1 is 10. Go to my table B on the formula sheet. And I look up and I see that for a 90% CI, I find my T star, which is right here, this 1.812. So find all your pieces of data, your X bar here, your S, the 6.9, your T star, your N is 11, and set up the formula for your CI. Okay, I put the formula here. Notice what we do now, though, is we call it the X bar of the diff. So whenever you're doing your notation like that, this is X bar of the diff, and this is the S of the diff. Subscript there. All right, after running all the math, you get this CI. So we've done our state, our plan, our do, and then our conclude now is we are 90% confident the true mean difference in the depression score is between 3 and 11. This means, now we're putting context, what does this mean? This means that depression rises in the caffeine dependent patients when given a placebo instead of caffeine. So all these patients, I guess, were caffeine dependent. They didn't get their caffeine. They got a placebo, and it did show that they need some help with the caffeine, I guess. All right. So notice it's all conclusion and context. Please do your best on your homework to make sure you say what that means. We're not just robots doing the CIs. You need to then turn around and say, okay, so I got this data. What the heck does this mean back into context? Okay. So that's just an example of a paired T sample for us. Okay. Now, I just have in here a few things that might show up on your multiple choice part of the test. There's a term called robust, and this does come up, and they ask you if something's robust or not. If we were in class, I'd ask you guys to turn to your partners and say, what does robust mean? You know, if you have a robust laugh, it's a very hearty, firm laugh. If you're robust in your strength, a person who's robust is seen as active and strong. So an inference procedure is called robust, strong, strong procedure. If the probability calculations involved in that procedure remain fairly accurate, even if one of the conditions is violated. If we had to proceed with caution, and we would still get the same thing, okay? So the problem is we saw that T is not robust because it's not robust against outliers. Outliers change the whole thing, and that's why we cannot use, if n is small, less than 30, we cannot use T interval with any confidence because it is not robust against those. If there's outliers, it's not robust against them. Because remember, X bar and S are not resistant to outliers. Outliers cause a big difference on them. And you know what's in our formula? X bar and S. So if those are really affected by outliers, then so would be the T star or the T procedure. Now, not the T star, sorry, but your T procedure, getting your T interval. Now, the bigger N gets, okay, and N is bigger and bigger, then of course, the less impact that has on it. It can be more robust, but T procedure itself is not. So Miss Drop, yay, calculator commands. Instead of doing all this by hand, there's a calculator command. So now for tonight's homework, instead of doing it all by hand, you would, what AP Stats requires is that you write down, like we've talked about before, what command you're using and what you're putting into your calculator. So let's see, how do you get your T interval? So you hopefully have your calculator handy. If not, would you go get it? By the way, for every one of our notes, have your calculator right with you, please, and your formula sheet. You're going to always need this for the rest of these lessons, almost every one. Okay, so if you've got your calculator now, go to stat tests button and go to 8, and you'll see 8 says T interval. Okay. If you have to use the calculator on your computer screen and you can't access this right now where you're watching notes, then make sure you get these instructions written down. Okay. Then it goes to input. Okay. And you pick data or stats. Data is if you're putting data into a list, then you need to choose the data command. Stats is chosen if you're given the statistics. If you're given X bar, you're given S, then you just go straight in and use stats. But if you're given data, you do data. So you choose either one. Right now we're just doing data because we're going to list one where the data is stored. So you tell it what list it's in, leave frequency the way it is, and now you put in your C level. We're going to do a 95% CI here, okay? And when you do, then you scroll down and you hit enter on the calculate, And voila, you will be given the confidence interval. It'll tell you what X bar is, what S is, and what N is. There's no need to really go run one of our stats because it gives it to you here, everything you need. And it gives you the confidence interval. So this will be so much faster and easier for you on your homework to just go use the calculator command for T. Now, we learned in 10.1, what if I do know the standard deviation of a population, then I use a Z interval. Okay, so remember T interval, Z interval. Okay, Z interval is, sorry, my son just came home from work. I have my own distractions here, don't I? All right, so stat tests. Now 7 was Z interval. Okay, I'm going to pause this. Sorry, we got, if I can, well, I guess I can't. We'll see if we can get through this. Just ignore the noise in the background. Input data, not stats, whatever. Basically, you'll do stats if you had it, but I'm giving you a list right now that you're looking at from your homework is what we're assuming. If you know sigma, that's where you will put it, and then give your list wherever your data is stored, whether it's L1, L2, L3. I just wrote L3 here for the heck of it. And then your CI level, and you hit calculate. So it's exactly the same thing. It's just now you have sigma instead of S, and you will get your Z confidence interval with X bar, S, and N given as well. However, that's information is not as needed, but X bar would be. Okay. That's it. Why don't you practice with your calculator on your homework tonight and see if you could get those used on office hour time. If you're struggling with any of that, I'll have my calculator out and we'll go through how to do that. All right, guys, next is section 3.